Alright, so you put some money in the bank, and every year the bank pays you some interest. And you leave that money in the bank for some amount of time. How much money will you have in the bank at the end? Now, one way you already know how to do this is using a recurrence relation. Drawing up a table that looks a little bit like this. At the start of year 0, we have $10,000. Now, at the start of year 1, we'll have $10,000 times 1.08. Or just $10,800. Now, here, 1 year later, we're going to have $10,800 times 1.08. But let's not write 10,800 because 10,800 came from this bit. So instead, I'm going to write 10,000 times 1.08 times 1.08. That's my 10,800, and then I'm going to multiply it one more time by 1.08, and that's going to be 11,664. Now, if I go down to my next year, I'm going to take that number and multiply it by 1.08. But that number is that number, right? So I can write this as 10,000 times 1.08 times 1.08 times 1.08 is equal to $12597.12. And you're probably getting a sense of this, right? So here, if I want to know year 1, I do 1.08. Here, if I want to do year 2, I do 1.08 times 1.08. If I want to do year 3, I do 1.08 times 1.08 times 1.08. Here, if I wanted to do year 4, you should know it's going to be 1.08 times 1.08 times 1 times 1, 4 times. Okay, there's a faster way to do that, however, because you know about powers. So instead of writing 1.08 times itself 4 times, a number multiplied by itself 4 times can be written as 1.08 to the power of 4. And that's going to be whatever my next number is. Now, knowing this is really, really useful because instead of using a recurrence relation and writing every single year of the 10 years, I can actually just jump straight to the 10 years. Because I can just write the number 10 in here, and I can say, using my pattern, that it's going to be equal to the money I started with, $10,000, times 1.08 to the power of 10. And now I'm sort of leaping forward in time. There's like a space here, and leaping forward to the 10-year mark, my number is $21,589.25. So that means that I didn't need this table at all. I just needed to start right down here and say, what's the money I started with? Let's multiply it by 1 plus the interest rate and raise that to the power of however many years I've got. And that is going to be our compound interest formula. So we don't need the table anymore. Let's get rid of this and let's add in a compound interest formula. This is my compound interest formula. A equals P bracket 1 plus I to the power of N. And that's what we did up here. Now, just to write down what all of these letters mean, A is the total amount. P is the principal. That's the money that we start with. Now, I is my interest rate. And you need to be really careful here because it's your interest rate as a decimal. Now, what do I mean by interest rate as a decimal? Well, this is 8%. And that as a decimal is 0.08. Okay, so just make sure that you're converting your percentages to decimals. And finally, we have N. And N is the number of compounding periods. Now, you might be thinking to yourself, wait, I think it's the number of years. Why are you saying number of compounding periods when it would be easier to say years? That's because in a future video, we're going to realize that compounding periods don't have to be years. Maybe they could be months or weeks or days. So we need to be very specific here. N is our number of compounding periods. So now that our horrible table isn't here, we can just sort of use this formula to find out the total amount that I'll have after 10 years. A is equal to P 1 plus I to the power of N, where P is the principal, the money that I started with. 1 plus I is 1 plus 0.08, because the interest rate is 8%. As a decimal, that's 0.08. Number of compounding periods is 10. And you can type that straight into your calculator. And there you have it. We've already done that once. Here it is a second time. Now, it doesn't matter what the question is. You could start with some other amount of money and some other interest rate and some other amount of time. And you could still use this formula by just plugging in our numbers. So we start with $7,500. We do 1 plus this as a decimal. Careful, because I put a decimal in there. So I have to move that 2 places to the left, and I'll get 0.0523. You can just divide it by 100. Type it into your calculator, divide by 100. You'd get this number here. And to the power of 6. And you can type that into your calculator. We get a number like that. And that's how much money I'll have in the bank after 6 years if I do this. Now, everything I've been talking about is putting money in a bank and earning interest. But this can also be used for loans. So you borrow $5,000 at 7.25% per annum over 8 years. And at the end of 8 years, you're going to pay that money back. How much interest does your loan accrue? Okay, so there is a little bit of a trick to this. Now, if you're thinking, I'm just going to shove it in the formula, it's going to spit out an answer and I'm finished, you're about 80% correct. But there is an extra little step here. So let's first of all put all of that information into our formula. The total amount that you owe, and that's an important statement, is equal to the principal, that's the money that you borrowed to begin with, and then 1 plus the interest rate, which is 0.0725. Remember, I'm turning that into a decimal, not a percentage. And then it's going to be over 8 years. Okay, if I type all of that into my calculator, I'll get something. This much, $8,752.83. And a lot of people in an exam where they were asked this question would stop. I did the compound interest formula, I shoved everything in, and I've got an answer. But they are wrong. Because that's not how much interest you accrued. That's how much you're going to have to give them back. They gave you $5,000, and at the end of the 8 years, you give them $8,752.83. But the interest that you owe them is the money that you borrowed to begin with, subtracted from this amount here. That is, the interest is equal to the total amount minus the principal. So the total amount that you owe at the end of this is $8,752.83. And the principal, the money that you borrowed at the start, is $5,000. So the interest that you were charged was $3,752.83. Alright, so we've got the compound interest formula. It's really great for finding total amounts at the end. But if you're not interested in the total amount, but you're instead interested in either how much interest you owe or how much interest you've received from the bank, then you're going to have to go the extra step and do total amount minus the principal, A minus P. Alright, that's the beginning of the compound interest formula. We've talked about where it came from, a recurrence relation. We've got a nice little formula here. We've put it in for a few different ways, and then we've sort of gone the extra step here. In maybe another video, we'll rearrange this so if you don't know N, or you don't know I, or you don't know P, you'll be able to find those other values.